6.1 is about angle measure. Angle consists of two rays which meet at the point. That intersection point is called a vertex. There are two parts in the angle. One part is called an initial side. The other part of the angle is called a terminal side. The way we understand the angle is we rotate the initial side to get to the terminal side. We can do it counterclockwise or clockwise. You can rotate the initial side as many times as you want. If you rotate the initial side to get to the terminal side counterclockwise, then that angle is called a positive angle. If we rotate the initial side to get to the terminal side, the angle is called a negative angle. This is clockwise rotation. Positive and negative are number sense. When we have an angle, we can measure the angle. There are two ways to measure an angle. Those are degree measure. The other is a radian measure. When we denote a degree measure, we denote it as number and a small right circle on the right top corner. Radian measure is described with a number. Here is the way to measure an angle. Let's suppose that initial side and terminal side are in the same position. Because we rotate the initial side counterclockwise and we made one full rotation. When that happens, we say that that is 360 degrees in degree measure. If we measure the same angle in a radian measure, then that angle is called 2 pi. Other angles are proportional. Let's go through the examples. We will put the initial side on the positive x-axis. We make 1/4 of the rotation counterclockwise. So the terminal side is identical to the positive y-axis. In this case, this is 1/4 of one full rotation. So we will simply multiply by 1/4 to the one full rotation. So we get 90 degrees. If we think about the radian measure, then that is 2 pi times 1/4. That can be written as 2/4 pi, which is 1/2 pi. Of course, we can write it down as pi/2. In this particular case, the angle has a special notation like this, and that is called a right angle. This time we have an initial side which coincide with the positive x-axis, but terminal side coincide with the negative x-axis. What happens here is this is 90 degrees and we go further same amount. So this angle will be 90 degrees plus 90 degrees, which is 180 degrees. We can say this, think the same thing. So this is pi/2 and 2 pi/2. That means that is pi. Or you can just say that that is the half turn of one full turn. Therefore, that is 180 degrees. Or one full turn was denoted by 2 pi. We made only a half turn. Therefore, that is pi. Let's do one more positive angle. We locate the initial side on the positive x-axis, but this time terminal side coincide with the negative y-axis. Each sector is 90 degrees, so 90 degrees, 180 degrees, 270 degrees. So that is 270 degrees. We do the same reasoning with radian measure. Pi/2, 2 pi/2, this is 3 pi/2. This time, we think about the negative angle. We will position the initial side and terminal side on the same place. So positive x-axis becomes initial side, and positive y-axis becomes terminal side. I said negative angle is obtained by rotating the initial side to terminal side clockwise. We go this way. This is a negative angle. We rotate it clockwise, so the angle value is negative. So each sector is 90 degrees, so 90, 180, 270. 270 degree, and negative pi over 2, negative 2 pi over 2, negative 3 pi over 2. This is an initial side, and this is a terminal side. But we rotate clockwise, then 90 degree, 180 degree, but that is a negative angle, so negative 180 degree. And again, we are thinking about negative degree, so minus pi over 2 and minus 2 pi over 2. So that is minus pi. Here is initial side. Negative y-axis is the terminal side. We just move one sector clockwise, so that is 90 degree, but that is clockwise, so we attach minus, and that can be considered as minus pi over 2. We have a special notation, so we write that notation there. We discussed radian measure and degree measure. We know that 360 degrees is 2 pi. So we discussed how do the angles correspond to each other. So whatever the angles given, either in degree or radian, we can convert that to the other angle measurement. Let's discuss conversion between radians and degrees. As I said, one full rotation is 360 degrees. That equals 2 pi. What we want to do is we want to think about the ratio. If we use 360 degrees equals 2 pi, then 2 times pi is a composite number. So we want to make the simpler expression. To do that, we divide by 2 on both sides. So left side becomes 180 degrees and right side becomes pi. So this ratio, this correspondence will be used when we think about the conversion between radians and degree. First example is express 60 degree in radian. We want to use the ratio. We will compare this given angle 60 degree with 180 degree. The angle in a radian mode is unknown, so we will put that as x. What we want to do is we will write the radian mode in the same place. 180 correspond to pi radian, and the unknown radian angle correspond to 60 degree. We have to solve for x, so we want to remove pi on both sides. So we will multiply by pi on both sides. So this same thing will cancel each other. So we get x on the right side and 60 times pi over, we can rewrite 180 as 60 times 3. So this 60 and this 60 will cancel each other. So we are getting x equals pi over 3. Express 41 degree in radian. Round to 3 decimal places. Again, we want to think about the ratio. We think about 41 degree and 180 degree. Now we want to compare the radian angles. Again, in radian, this angle is unknown, so we will put that as x. That x corresponds to 41 degree and pi corresponds to 180 degree. The way we conclude the problem is the same, but in this case, 41 is a prime number, so this fraction cannot be simplified further. On the right side, pi and pi will cancel each other, and we have x here. On the left side, we have 41 pi over 180. Of course, 41 pi means 41 times pi. Let's use the calculator. 41 times pi divided by 180. We have to round it to 3 decimal places, so 7155 becomes 7156. X is approximately 0.71 0.16. The next problem is the other way around. We have a radian measure of the angle. We want to convert that radian angle pi over 6 in degree. We do the same thing, but on the left side, let's compare the radian angles. Pi over 6. We compare that with pi. On the right side, we are thinking about the ratio of the degrees. Pi corresponds to 180 degree, and we know this degree, which corresponds to pi over 6, so we will put x on the numerator. There is a little bit inconvenient aspect of this problem because on the numerator there is a fraction. To make this expression a little bit simpler, what we want to use is this kind of formula. A over B equals A times 1 over B, because A can be written as A over 1, and when we multiply that, we get A over B. Let's say we have 3 over 5 here, then we can say that that is 3 over 1 times 1 over 5. So we can also say that is 3 times 1 over 5. What I'm trying to say is this A can be written separately. That is a numerator. On the left side, the numerator is pi over 6. So we write pi over 6 and multiply that to 1 over pi. That equals x over 180. By converting the expression like this, we can see things clearer. We can see that this pi and this pi will cancel each other. On the left side, we have 1 over 6. On the right side, we have x over 180. To get x by itself on the right side, we multiply by 180. (180) can be written as 6 times 30 over 6. This 180 and this 180 will cancel each other. So this 6 and this 6 will cancel each other, so x equals 30. So 30 degree correspond to pi over 6. The next example is about expressing 4 radian in degree. We want to round to 1 decimal place. Radian is given, so let's compare that with pi. Pi over 4. Again, degree corresponding to 4 radian will be written as x. Pi corresponds to 180 degree. To get x by itself on the right side, let's multiply by 180 degree on both sides. These two will cancel each other. So x becomes 4 times 180 over pi. The problem is asking you to round to one decimal place. So we have to use calculator. That is 4 times 180 degree divided by pi. The second decimal point is 8, so we can say that the final answer is 229.2 degree. We've been talking about converting degree to radian and radian to degree. There are common angles which we will use very frequently, and people usually don't think about degree conversion. Instead, people tend to just think right away that 90 degree is pi over 2. So you have to remember 45 degree will be pi over 4 because those are half. 1/3 of that is 30 degree. That is pi over 6 by multiplying by 1/3 on both sides. And 60 degree is twice more than this. That is pi over 3. Of course, you already know 180 degree is pi. All of those are the angles which you have to remember, because those will be used frequently. When we discuss 90, 120, 270 degree, we put all the initial side on the positive x-axis. When we put the initial side on the positive axis so that the positive x-axis and the initial side coincide, that angle is called the angle in standard position. DEF means definition. We say an angle is in standard position. If the initial side of an angle coincides with the positive x-axis, For example, let's say this is a positive x-axis and that is the initial side. We rotate the initial side and we get to this terminal side. Terminal side can be anywhere. This is the example of the angle in standard position. Another example may be, again, the positive x-axis coincide with initial side. And we rotate it this time clockwise to get to the terminal side. This is again the angle in standard position. Two angles are coterminal angles. If they share the same initial and terminal side, we've seen some coterminal angles already. For example, this angle and this negative angle are coterminal angles. Again, this angle and this angle are coterminal angles. Let's think about the angle in standard position. Let's assume that this is the terminal side. We get to the terminal side by counterclockwise rotation. This is the initial side. Exactly in the same position, we have a terminal side. This time we get to the point, counterclockwise rotation, but we make one more turn and then go further. Those two are coterminal angles, but we think about the coterminal angles which are negative angle. Let's say we rotate the initial side clockwise like this to get to the same terminal side. Then these will be coterminal angles. One more example. Again, the terminal side is located in the same position, but we make one more turn to get to there. All four angles are so-called coterminal angles, so they share the same initial and terminal side. If we go back to the simpler example, when we compare these two, one is 90 degrees and the other was minus 270 degrees. When we think about the difference between these two angles, then we have to say something like 90 degree minus 270 degree, then that is 90 plus 270, which is 360 degree. When we pull out this example, one angle is 180 degree and the other is minus 180 degree. So when we think about the difference, we have to subtract the other angle. So we have 180 minus 180 degree. That is 180 degree plus 180 degree. That becomes 360 degree. You can see that the differences between those angles become 360 degree. But depending on how many rotations you make, it may become a multiple of 360 degree. If we describe the same circumstance with radian measure, then we say that the coterminal angles are different by the multiple of 2 pi. The differences between coterminal angles are the multiple of 360 in degree or the multiple of 2 pi in radian. Let's do an example. Find an angle between 0 degree and 360 degree. That is coterminal with 390 degree. The first thing you can notice from here is the angle 390 degrees is pretty big. That is more than 360 degree. What we know is 360 degrees is one full rotation counterclockwise. So maybe the angle rotated more than once. What we pointed out was the differences in coterminal angles should be multiple of 360 degree. So in this case, all we have to do is 390 degree minus 360 degree. That becomes 30 degree. Here is an angle. What happened was, in other words, we can write that 390 degree equals 360 degree plus 30 degree. Geometrically, that means this is one full rotation and go a little bit further by 30 degree amount. So 390 degree will be one full rotation and then go further with 30 degree. So this is 390 degree and this is 30 degree. What we are saying is both two angles are called coterminal angle. Next example is about find an angle between 0 and 2 pi that is coterminal with 23 pi over 6. This time we are discussing the radian angles. The angle is given with fraction 23 pi over 6. We have to compare that fraction with 2 pi. 2 pi is not a fraction, so it's better to convert that into fraction with denominator 6. So let's write 2 pi as 2 pi over 1. We want to make the denominator 6, so we multiply by 6 on the denominator and multiply 6 on the numerator. Then 2 times 6 will make 12 pi. When we compare this, which is one full rotation, with this number is larger. So what we attempt to do is we subtract this number from here and see what happens. 23 pi over 6 minus 12 pi over 6. We have the same denominator 6, so we can do 23 pi minus 12 pi. Then that'll be 11 pi over 6. When we compare 11 pi over 6 with 12 pi over 6, that is smaller. That means that fraction is less than pi over 2. It is a positive number, so that angle falls between 0 and 2 pi. So that is the desired answer. Let's locate the angle. We have to locate the angle 11 pi over 6. That is a little less than 2 pi, which is 12 pi over 6. So this is the initial side. That initial side can be expressed as 0. If we think about 2 pi, then that can be expressed as 12 pi over 6. 11 pi over 6 is a little less than 12 pi over 6, so you can easily imagine that the angle is located in the fourth quadrant. This amount is 11 pi over 6. If we think about 23 pi over 6, then that'll be one more rotation. So we make one full rotation and then we go 11 pi over 6 amount more, like this. This angle is 23 pi over 6. Those two angles are coterminal angles. If the fraction or angle measurement becomes much bigger, like instead of 390, if the angle is like 840, then you can just keep subtracting 360. In this case, you will keep subtracting 2 pi if the angle doesn't fall into the range between 0 and 2 pi. There are some formulas which you have to remember. The first one is about arc length formula. Arc length formula is given as radius times radian angle. Whenever we state the formula, we tend to use radian angle. Let's visualize. We have a circle here. This is a radius. We are thinking about this measurement, theta in radian. We want to think about the length between this point and this point. Let's denote that as S. Then arc length formula can be written as S equals R times theta. Second formula is angular speed. We think about the change in angle in a unit period of time. So radian angle divided by time. When we denote the angular speed, we tend to denote that with Greek letter. This is not W. You will read that as omega. Omega equals radian angle was denoted as theta, and time is denoted as t. Theta over t. When we discuss the angular speed that is associated with time and radian angle, it is not associated with radian. Let's think about the linear speed. This time we are thinking about the object which moves around the circle. So when we think about the distance between one point and the other point, we have to calculate the arc length. So the formula goes like arc length divided by time. Arc length was denoted by S, so linear speed V equals S over T. Let's do an example. Find the length S of the circular arc Let's say this angle is 2 pi over 3 and radius is 8. This length is S. We want to think about the arc length S. This is a straightforward question. We just use the formula. Arc length is defined as R times theta. So we just multiply by theta to R, 8. So 8 times 2 pi over 3. 8 can be written as 8 over 1. The numerator will be multiplied together. So 16 pi over 3. Next example is the real-life application problem. A ceiling fan with 24 inches blades at 55 RPM. The first question is about finding the angular speed of the fan in radian per minute. If you read the instruction, then a ceiling fan with 24 inches blade at 55 RPM. The first thing we have to know is what it means by RPM. RPM stands for revolution per minutes. RPM measures the speed the ceiling fan moves. But this time, we want to think about the speed by using an angular speed. So the first problem is related to the unit conversion. "55 RPM to angle." Let's say, revolution. That's the first thing we have to think about. We know that one revolution in angle is 2 pi. We are thinking about 55 revolution. Revolution is 55 times 2 pi, which is 110 pi. So this gives us the amount of angle is spent in a minute. Now we use the angular speed omega. Omega is theta over t. Theta is 55 revolution, which could be converted to 110 pi, divided by the unit period of time is minutes, so 1 minute. So that is 110 pi. That is radian per minute. 1 minute doesn't have to be denoted, so that's embedded in the unit, radian per minute. 110 pi radian per minute is the final answer. The second question is about find the linear speed of the tips of the blade inches per minute. If you remember what I was talking about when I introduced you the linear speed, this is theta, this is r. We are thinking about the distance between this one and this one, and based on that, we have to think about the linear speed. So this is s, right? Linear speed v equals distance it moved divided by the time. That s is the arc length because the particle is moving along the circle. So that can be calculated as r times theta over t. In this problem, the ceiling fan is 24 inches, so 24 times, they said 55 RPM. When we convert that to angle measurement, that is 110 pi. Divided by 1 minute. So you have to use calculator. Of course, in this problem, they are just asking you like find the linear speed, but they didn't give us any instruction about how to approximate. That means they're wanting to get the exact answer. So we don't put pi in the calculator. Instead, we just calculate 24 times 110. That is 2,640. Leave pi as it is. That is 2,640 pi inches per minute.